and we understand what pointers are and what they do. But then in this particular class, I want just achieve some practice on pointers.
Okay, that's okay.
But before that, someone was talking about arrays, and well, I would say arrays are not pointers per se, but they really go together because an array an array is simply a contiguous block of memory that is given to store something.
Can you come again on that?
I'm just saying an array is a contiguous block of memory that stores a particular value. So for example, if we were to do this, so for example, when you declare a variable, when you declare a variable, so when you declare a variable, so I'll be since the class hasn't officially started, I'll be avoiding the Betty style check. So when you declare a variable, like say for example, say you declare int x, what the compiler does is that it segregates a place in memory. In the memory, it segregates a place to store this particular variable. Up to there, we are clear, right, guys?
Yes, yes.
So
Yes, yeah.
it segregates a place to store this particular variable. Now, what a pointer does, so that's just that. So the thing to realize is that these variables are stored differently because an int will take 4 bytes, a char will take 1 byte. Okay, but mostly it's machine dependent, which is why the size of operator becomes very crucial. But the thing to understand is that this character, the type of the variable matters because it will store things differently. Because an int won't be stored the same way a char will be stored, because a char will have a different memory. Will have, say for example, just 8 bits allocated for it. An int will have 32 bits and such according to the machine. So what a pointer is, it's the address. Okay, it gives the address of that particular variable, and then I think now we understand. So when you add to a pointer, it counts the number of variables, number of spaces, and that's how pointer arithmetics typically works. So, but I think we all understand that. So as for arrays and string arrays are simply a contiguous block of memory. So for example, if we did this, if we say 67, we said 67 like that. If we said 67, then what that simply means is that the compiler, the machine, the program would set 67 contiguous. The contiguous, I mean the ones that follow each other. 67 spaces for allocating just integers like that. When I've written like that 67, okay. But you don't have to do this. You could also write like, then you initialize it. So you will say 56, 78, 87, 98, and just like that, it would be an array of 4. So if we were to look at the size, then if we were to look at the size of this, size of x, okay, so size of x in this particular case, it would print 1 2 3 4. It would print now the size. So let's look at size of so let's see the size of x and size of an int. Size of x on this particular machine, then size of int. Then we have the operator given. Okay. So when we compile this, oh, I'm having some errors. Let me see. Has to type long unsigned int. Has type long unsigned int. Okay, so let me fix that. lu instead of so I didn't get to save it. Sorry about that. And so let's see again. So this time let me save it. Lu, then we have that. So then we have, so when we compile it, it compiles, and then when we run it, so x has a size of 16, as you can see in this particular place, and that's the size of an integer according to this machine is 4 bytes. So as you can see, the x is an array of 4 integers, so therefore it has allocated a size of 16 bytes in this particular case, 16 bytes for the entire array. So that way you can store 4 integers in that array. So I think that's clear. But then that's not really the point of this particular session. This session we're supposed to be we're supposed to be practicing pointers. Now here's another note on arrays. So when we go back to the example we gave, this particular case, so an array in this particular case, so we know that a pointer is it gives the variable it's a variable that stores the address of another variable. So its value is the address. So let me now finish. The return is always 0 because it will always be successful. So that's that. So another thing to understand is that when you print x just like that, so when you print x, for example, so when you print x, x will decay to the pointer. It will give the pointer to the beginning, the address of the very first, what is it called? The very first element, the very first array element in memory. And so that's that. And then so well, but then when you increment it, it won't increment by an integer, by the size of an integer. It rather it will increment by the size of the entire array. So for example, if we were to print, so the value of x now, if you were to print that, then we give x. So let's also add a new line, and then we then increment x. So just after this we increment x, say x plus plus, then we say again a new line, we say percent %p, the value of x after increment, okay. So this time when we compile, you'll see, avoid point, oh I remember, so this one won't compile with the normal flags unless we remove all warnings as errors. L value required as increment operator. Okay. So let's see the left value, the locator value.
In the printf, the second printf function, you did not add the value that you are going to print.
Okay. Let me see. Moment. Oh yeah, that's true. I did not do that. X. Why isn't it compiling? Assignment to expression. Okay, this actually gives me an error. I think it's because of the C99. It gives me an error. So it just goes on to show you can't perform pointer arithmetic. This is an array. An array is not a pointer. I think when you go to arrays more tomorrow, you'll get to understand. But the thing I want you to get for this particular session, actually, the thing I want you to get in this particular session is this actually. So you understand we can dereference pointers in various ways. So for example, if we did this, so if we had this, so we have this, if we had this as a pointer to x, right? And then we said int, then we said int y, we not confuse you right now. So then we said int y is equals to 90. Then we said x, we initialize x, we give x the address of y. Okay, so but this will be better seen using a string. Let me not use integers. This example would be better seen using a string. So if we let's try to use the string compare function. So let me include the string header file. So let's first look at a simple string that calculates the length of the string. So let's see. This is a simple one. We've done this. It gets the length of a string. Then we have string. Then it returns the length. So we have instance and int, which is the length. So that's that. Now, in this particular case, so I'm first going to declare an iterator. Then I'm going to declare the length and initialize it to 0. Now, here's the thing about arrays. So you've heard that array counting starts at 0, right? Guys,
Yes.
so you've heard that when you count an array, you begin at 0. So,
Yes.
so the thing I want you to get is that here, so look at the way, so there are two ways of doing this. So you can look at the value of this. So the one way of writing this code is by using pointer arithmetic like this. Value of this plus the iterator, and then we make sure that this value is not equal to null. So this value here is not equal to null. Okay, and then we increment the iterator. Now there's that not equal to the iterator. Then we increment the length. Then you return the length. Return the length like that. So this code would work. It would work fine, actually. I think so. Let's try it and see. So let's say and we said get the length of this string. and yeah, like that actually. So we have that. Then we say int len1 is equals to use the standard one. It gets the value like that. Then hours len2 again, and let's compare. So and then we print out, say hours prints, then int d, while the standard prints. Okay, so ours is len2, and the standard one will print len1. Okay, so let's compile this and run. So of course in this particular case, I'm still using a.out. So as you can see, both of them return 31. Both of them count 31 characters. So here's what I want you to see actually. So when you use an array, here in this particular code, I've dereferenced the pointer at this particular addresses. It's clear here. You can see I've dereferenced the pointer. Another simpler way of doing it is by using arrays. So when you have a pointer at a particular location, when you declare an array, like when you declare an array, an array simply gives you the position. How do I say this? When you use arrays like this, it will give you the position, the value at that, it will dereference that pointer at that particular position. So in this particular case, when iter is 0, it will dereference the pointer at the value of 0 and check that character. So in this particular way, the code would work fine. Let's see first. And as you can see, it works the same way. Now, so in this particular case, let me just explain my code before I go, so to ensure everyone understands it. So when you use an array, when you use this array in this particular case, an array is a continuous block of memory. So when you use this array, when you give it a value here, when you're not declaring it, when you're getting that value, it will dereference. It will perform a dereferencing, an automatic dereferencing of that particular pointer. And that's why when you print an array, when you print an array just like that, it will give you an address. It will decay to a pointer. So when you use an array like this, it dereferences the value for you, so that you don't have to if you don't really understand pointer arithmetic, but you can tell the address, you can use arrays for that matter. I don't know if is that clear for everybody, guys?
Can you please explain that point again?
I'm saying an array, when you use an array, when you give it an address, the way I've done here in line, let me put line numbers. So in line, okay, a moment, display line numbers mode, yes, disabled. Oh, is that? No, in this buffer. Sorry guys, I was using the wrong buffer. So yeah, in line 12, you can see in line 12, okay. So keep in mind this str here, this str, it's a variable that is given as the argument in line 8. Up to there we are together, right?
Yes.
So this str is a pointer that is given as the argument. But instead of dereferencing it and taking it dereferencing the address at that particular point, I'm using an array. So the array, what it does is that it takes the value at that point, okay, at that particular point. From that, it performs the pointer arithmetic for you. So in this particular case, instead of writing like I had done first, okay. So let's see another way of writing this. So in this particular, instead of writing, so you understand this actually. This you understand, right? Because
Yes.
I'm dereferencing the pointer at this particular address, right?
Yes.
I'm adding it like this, so and then I'm dereferencing it. So instead of writing this seems bulky. It's bulky for me. I'm using an array to simply get the value instead of dereferencing it myself. An array also it simply dereferences it for you. I don't know if that's clear. Is that clear for you guys?
Yes.
Yes.
So that so in case you this syntax if this syntax seems so hard for you, if the syntax for pointer arithmetic seems so hard for you, you can simply use the array declaration, and in that way you'll just get you'll just dereference it very well, and it would be much cleaner and easier for you to understand. So now that's just so here we're just getting the length of a string. So you're given a string and you get its length. I think that's clear. So in this particular case, so the way I'm realizing here, all strings in C are assumed to end with a null byte. This null byte, they are assumed to end with a null byte. So as soon as it reaches the null byte, I get the I stop the loop and I get the length. So and I'm looking so I'm starting to count from one, and I increment the length for each character, but when it gets the null byte it won't count it. It will exit the loop and return the given length. Okay, up to there we're together.
Yes.
Okay, so so now that's done. So there are a few functions I wanted us to make. The next one is the string compare function. So let me just open my terminal. This is str compare. This string compare function. So this function it's actually quite a tricky for me. So it takes, let's say it compares two strings and it returns an integer indicating the result of the comparison. It takes the two strings as here. So here it returns an integer less than equal to, and it to match or be greater than S2. Now this manual, the man pages in this particular case, they don't really give much. They just tell you they compare and they return a negative value and a positive value. So a negative, what you can get from here, since you're saying a negative value if S1 is less than S2, then that just simply tells you we are taking S1 minus S2 and returning that. Okay, so that's just that. Now what you can get from Google, when I googled this when I was researching string compare, and I realized it compares the characters and it returns the value. Is it? It returns the value of the at the point in which they don't compare, then it returns the value. That's the difference it returns here. So that's according to glibc, according to the C standard library, it returns the value like that. So here,
Are we recording that session?
yeah, I'm recording it. So here, it returns an integer. It gets the subtractions and returns them. Now, strings are null terminated. So you know that whenever you get to the null byte, the string has ended. Okay? So that's a a neat trick for you to always remember. Whenever you get to the null byte, the string has ended. Okay? So we have string compare. String compare compares two strings. So here it compares two strings, returns the difference. So we can say it emulates the standard string compare function. So this one takes two arguments. So we have string one and string two. the difference. Now here you instead of having string length, we'll take string compare, then we'll have str, and then we'll have str2. So in this particular case, let's start. So we'll have a difference. So we'll have a difference. The difference would be 0 in the beginning. Difference equals to 0. That will be the difference. Then of course we'll have an iterator. Iter simply means iterator, something to iterate through both strings. So this one will also begin at 0. Then that's just that. So those are the only ones we'll have. So we'll say equals to 0. Then we'll have the first thing. So we'll have the iter. So as long as this is equal, so we're going to have several conditions in this for loop. So you'll have str and then str2. So you notice here I'm still using arrays. Okay, I'm still using arrays to dereference my values instead of actually now working with pointer arithmetic, because that tends to get a bit bulky for me. But you guys are understanding the code, right?
Yes, yes.
Okay, and if you don't understand, just tell me. There's really no point in not understanding. Okay, so then we say, and this is not equal to null, because when it gets to null, the string has ended and there's no point in going on. Although this may be considered redundant, thing as when it gets to null, they will no longer be equal unless both of them are null. And str2 is not equal to no. So let's do that. So I think you guys are starting to appreciate why I liked them. Not equal to null, and then we increment the iterator. So we say difference, we update difference, and then we say minus str2, then we say return the difference. Now we update the difference, then we return it. We update the difference first. We update the difference because when they are not equal, that difference will not have been calculated. So therefore we have just update the difference before, then we return the difference here. Yeah, that should work fine. Okay, so in our main we take 2 pointers. Let's start with one that is equal. Oh, I wrote that. And then so let's see. So here you'll have the standard string compare function in the string header file. Then we'll use str and str2. Then here still the same. So let's compile this and run. Then we'll also use the pedantic. Oh, sorry. I forgot to rename the string length function seeing as I used the same.
Mr. Sammy,
Yes. Yes. I'm listening.
what does string length do? It gets the length of the string, right?
Yeah, the string length gets the length of the string. But in this particular case, I'm comparing. So this works fine. I think you're starting to see how easy it is. So let me try to show it. Let me show something. So seeing as most of this would be redundant, because once they're no longer equal, then the null terminator byte will no longer be needed. So let's see. Oh, I got a segmentation. Why is that? Z shell. So in this particular case, I take the difference and I iterate for as long as they are equal, right? And when they are null, they don't stop. They go on. And that's why I needed the null terminating byte. So I should have written and they are equal. So that's why I got. So if you remember in my previous code, I didn't commit it, but did I? No, I didn't commit it. So I can't go back to it. I can't git log and go back to it. But so you remember, I said I looked at this condition. So as long as they are equal, it should continue looping, right? And then I said as long as this exists, as long as this one exists and is not equal to null, and as long as the other one, okay, so that at that point whenever the other one gets to null, when it gets to null immediately, it then exits the loop. But then now that when I removed these conditions, when I removed the conditions, I got a segmentation fault. And why is that? It's because the loop kept running, and when it got to null, they continued because I don't know the other ones, the other parts, the other values after the null byte. I didn't know them, and that created an error for me. Okay. Okay, so that's that. Now that's the string compare function. Now when I was
I have a question.
yes, ask
Can you try to use a different string so that you can see how it works?
a different string.
Yes.
Okay. So which string do you have in mind? So let's
Like you can use another, like they should not be the same, yeah.
trial one in this particular case.
Mm-hmm.
Okay. Let's see. There you go. And you have it. Okay. So let's use one. I see a point. I didn't really explain how string compare works. String compare. It
Yeah.
compares two strings. So let's see. Trial.
Can you make the screen bigger? Like this other, the code is not appearing fully. Yeah, better.
Okay. So here, so the way string compare works is that it takes two strings and it compares the letters, the bytes. Okay, it compares the bytes. Each value, the value of each character from one until it gets to the end of one. Okay. So it gets the value, and then when it subtracts the SI value of each of the characters. Okay, Inasha. Did I pronounce your name right? It gets it.
Yes.
So it's, for example, it takes the SK value of T, and in this case it takes the SK value of this T and it subtracts this one. It subtracts R. It subtracts. If they are equal, then it will return 0. If all the letters are the same, it will return 0. However, if there is a difference, if one of the strings at some point they are not equal, and at the first point in where they are not equal, it then returns that difference, okay? And returns the difference of the first argument minus the second argument. Okay? Is that
Yes.
is that clear?
Yes.
Okay. So that's all I'm
So
doing here. Yes.
the difference, if STR1 is T and STR2 is S, what will happen? The difference.
The difference it calculates is in the SKI values. Okay. So a moment.
Oh, you mean this SI
Yeah, this
standard what?
yeah, these values here, these ones here. Okay. So you can see T has a value of, what is the decimal value? Okay, so T has a decimal value of 84 and S has a decimal value of 83, an SKI value, a decimal SKI value of 83. So therefore it will take 84 minus 83. Do you get it?
Yes.
Okay, so those are the values it would now get the difference of. Okay, so that's the difference it would calculate. After it calculates that, it then returns the value, the difference, and if they are equal, it would simply return a 0.
Okay, so for example, in the string that you have provided, we have a string that is longer than the other. So when the first string gets to the null terminator, will the comparison continue?
No, it won't continue. It would stop there. That's why I put this. Sorry. Let me use. Okay. It won't continue. It would stop at that particular point. So that's why I put this here. This one here. So I said, well, this one is equal and it's not equal to null. After it gets to null, it stops at that particular point. It does not continue.
Okay,
Okay.
yeah,
That's why
thank you.
this condition here. Okay. For either of the strings gets the null terminating byte, it stops at that particular point. Okay. Any other question? Any other question? Okay. So let's go on to another function. This is the STRSPN. I haven't forgotten how what it does. STRSPN. Oh, this one gets the length of the prefix substring. Now, in this particular case here, you can see the STRSPN, it calculates the length of the initial segment of S, which consists entirely of bytes in accept. Okay. Now this is a little bit tricky to understand, but the thing it does is that it checks for the length of X and compares them with the values in accept, and it gets the length, okay, the length in which they accept. So for example, so let me see insert mode. So for example, we have to, if you had two strings, you say trial 2, and then you have here trial 2. So as you can see in this particular case, TR and TR, these, if this that they accept, it checks trace 2. So in this particular case, it will just take the length for which this initial length, the prefix, you understand what a prefix is, for which R, so in this case it will be 2, is equal to the initial ones here. So it would start comparing from 0. If they are not, it would simply return 0. So it takes the prefix, the first values, okay? It's almost like the string compare, but it takes the first values of a string, if they are equal to the one that you've given. Okay, so it takes the first argument, in this case str, and it checks if the first values consist entirely of the characters given in str2 in this particular case. Okay, is that clear for you guys? Is that understood what it does? The STR span.
Does it mean it will take the values of the accepts
It will
and
check them.
compare
Yeah, it will check them.
all of them?
Not all of them, just those that are, it will check the values of accept for until it gets to the point where they are no longer equal. Once accept is terminated, then it will now no longer now check them. It will stop at that particular point and return the length.
So it works almost the same as the string accept.
In string compare here, it works almost the same.
Compare, mean. Okay.
It works the length. It gets the length of a prefix substring. It works almost the same as the string compare.
Okay.
So let's try to see if we can actually make it. Just a question here. Did you guys attempt the or is it these tasks? Did you guys attempt them when they were given in LX?
Yes.
Okay. So okay. So string span. So we should say gets the length of a prefix substring. Okay, that's that. So I've even forgotten where were we checking the substring at? So the length of a calculate in the initial the initial segment of S, and S is the first argument which consists entirely. So it checks the values of accept against the values of S. Okay, now that that is clear. Now that that is clear, let's look at that string span. Well, the string, and accept is the prefix to be checked. So it would simply check how many values. So here we'll have so we'll have a length, so we won't have a difference, and of course an iterator. So the length would be 0. So in this particular case, let's see how we'll modify this for loop. Draw plus u3. Okay, kill all these lines. So we'd say we'd initialize it to 0. Then we'd look at, so with the str2 is the prefix. So we would exit immediately. STR2 is no longer equal to the value at STR, so we would exit the loop. Okay, so for STR2, the values at STR2 must be equal to the values at STR. Okay, and then also it should, when we get to the end, when we get to the end of STR2, we should also quit actually. So STR2 is not equal to null. Okay, so we have that, and if STR2 is also too slow, we should actually go on STR. Now the problem with this, so I've activated the Betty checks, so let me use V to be clearer, for it to be clearer for you guys. Okay, so we have here it's not equal to null. Okay, then we increment, then we simply increment the length, and then we'll return the length. So let's see if this code will work as intended. So in line, so it checks, so it initializes and it checks if STR2 is equal to that value. If they are equal and it's not null and this one is not null, this one simply increments the length. And if they are not equal, it will simply stop execution and return the length at that given point. So in this particular case, so let's see STRSPN. So in this particular case, I think it should return 2, right? So wow, yeah, thank you. I was returns to the one prints 9. Now why is that? Let's see where we went wrong. We are right. Let's see. Returns 9. Okay. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. So where did the 1 come from? String span. Ours prints 6, while the string the standard prints 9. Okay. Could you help me see where the problem is? Unless so if it works the same way, if it works the same way as the STR one given in the standard in glibc, which consists of entirely the length in bytes of the initial segment, which consists entirely of bytes in accept, not in reject, which consists entirely of bytes in accept. There's something we're missing. I can't remember what. So let's look at it. Let's try to see Google. Let's consult Google. So, I recently borrowed. So let's see. So here, which consists entirely of bytes in accept. So I'm getting the length of a prefix. So that's it. It calculates the length of the initial segment. So, okay, this just repeats the man pages. Okay, I'm getting the length of the prefix. There should be something in glibc that we're missing. A moment. Get the length of a prefix substring. So then it's also not very helpful. String span. Oh yeah, I remember. So I remember. I think I see what we're missing. Checks the number of characters. In this particular case, it should print 4. String span. Tier 1. 4. Let's see. Okay. So let me first clear Emacs. Get out. So 6 and the standard one prints 9. Okay. So where has it got the 9? Where did it get the 9? STR2. So it, and once it stopped, they stopped being equal, it stopped printing. Now where did it get the 9? The definition of none1. Oh, so that's what happened. So what should be Allen to? House prints. That should be fine now. Prints now. Where did it get the 9 from? What am I missing here? Someone help me out. Where am I missing? So let me see if when they're exactly equal. What am I missing in this particular? String span in S2. I see it continued counting. It continued counting till for all the characters that were there. Why is it counting then 9 characters? 1, 2, 3, 4, 5, 6, 7, 8, 9. But the moment we have it should stop. It should stop. So it stops whenever when they don't get what to. Okay, that's fine. That was fine. I think I have figured it out. It will search for a character. The string span. It will search for. It will look. It will look for. Yeah, I think I figured it out. This is the standard one prints 9, and it prints 9 because once it encounters, it will look through the entire string of string 2, and then it will check for all these characters if that character is in this particular string, and that's how it will do it. I think I figured it out because As you can see in this particular case, these are 6, 7, then 8, 9. And then as it goes on, it loops through this particular string, and once it finds that character, it stops at that particular point and increments the length, and only then does it increment the length. But it will loop through the entire string too. So in this particular case, I need to stop printing. I need to stop comparing only the prefix alone and just loop through string 2. I need to loop through string 2. And if that character, I need to loop through string 2. I just need to loop through string 2. I'm looking to emulate. So I'm looping through string 2 and I'm looking at each character in string 2. If that character is equal to a character in string 1, and then I move on like that. And then I check if they're equal, because here I will look at it and then move on. String 2, check if this one is equal to a character here, and then I would simply move on until str is over. Say, so I'll say. So are you guys still with me? Are you guys still with me?
Yes.
Okay, Diana. So I need to check if that character is if the character given in string 2 is in str1, and I think in this particular case we should be using the STRCHR function. Yeah, it locates a character in a string. Okay, but then I think we should just do a strc, just locate the characters, and then after that we'll be done. But then for the first characters must equal. Actually, so I would do that. So I would say I would look through string 2, then check for each if the character given, if I would check if brackets str2, if the character given is in str. So I would simply say while brackets str is not equal to null. Sorry. Yes, who's talking? Then sorry. So while it's not equal to null, say if it's there, if str2, if it's there, if str2 is equal to str, then we increment the length, then we increment the length, then we break out of the loop. We increment the length, then we break out of the loop. We should also break out of the other one, then we should continue like that. So let's see. So we compile this. So what was the error?
You have a parenthesis that is.
Parenthesis error.
No, you're supposed to remove it.
Oh,
Yes.
Why is it not seg fault? Add or out. And then let's see what's taking it so long. It shouldn't be taking that long. I'm an Emacs user, so you'll forgive me for switching. And then to return the length, so it will check if this one is equal to the value. Oh, and you should also increment str. Sorry, very sorry to do that. No, I'm still having an infinite loop somewhere. Let me check my code again, especially the wire. Well, str is not equal to now if then break out of the loop. So we have that. I don't would actually. No, it shouldn't increment here. It should increment after. Let's print one on the standard. Is it printing one? It should continue. Nine. Okay. So str plus plus and str is the prefix. The prefix is str2. It goes through the entire and then goes through the entire string. And if it is, it breaks out of the loop and continues. And it increments the length. Only then does it increment the length. So why is it not working? How did you guys attempt this question? Let me see what I did. There's something I'm missing. There's what is it? I remember I used the so I located the character and I checked if I looked through the entire character and until now. STRCHR, it finds the first occurrence of a character. But then in this particular case, what was I doing? I said while this one could locate the acceptor, it could locate this character, it could locate the character, give this string, while it could locate this string in the acceptor string, increment the length. Diana, it seems like you're the only one listening.
Yeah.
Okay. Did you manage to do this task? You?
I think I have not gotten to that point. I got to the acceptor point. Then
No, I remember. This. This was simple. I see this the STRCHR it simply located a character in a string. So it looked through the entire string in this particular case, the S, and then it locates the character and it returns the or is it returns the location of that character. So that's why it is given. But then if it is null, then it returns null. If then it's null, then it simply returns that particular point. So that's that. But then in this particular the string span, what I was doing is that if it was null, I simply returned 0, which is here in this particular case. But in this particular case, I was looping through I was looping through the entire of these characters, and this the prefix. Except is the prefix, right?
Yes.
Yeah. Except the length in bytes, which consists entirely of the initial segment. Accept is the prefix. Accept is the prefix. So that's that. So that's that. Accept is the prefix. So it looked through the entirety of this one. And as long as the character accept is the prefix, and as long as the character in the length in you see it now, as long as the character in the given string could be located in the prefix, it could continue counting. It would now continue counting the length. So as long as the character in the given string could be continued, it will continue counting. So in this particular case, as long as the character in the given string could now be the given string could be located in the prefix, it would continue counting. That's what I think we were missing. So okay, so let's see. So as long as the character, so this str2 is the prefix, and as long as the character, you will loop through the string, and as long as the character in the string can be found in the prefix, it counts. That's correct, right?
Yes.
Yeah. That's what we are missing. We simply count, we go through the string and we count how many characters in that string are found in the prefix. And now for this particular one, now I'm trying to use it without using the locator, the string locator. So, so we are not looping through. We are not looping through str2. We are looping through str. Then that's that. Then we say, well, no, let me just use a second iterator. Then say str2. As long as the character in the string can be found in the prefix, count, then stop, exit the loop. Two. So as long as the character in the string, and so we look, this character, if we look with the character, if this str is equal to str2, str2, and that's that. Then, so if it is, then we increment the length, then we break out of the loop, then we go on. So this break statement would break out of this entire loop. And if it doesn't work, and of course, so most people I see they can't read syntax, so there's something I was missing. So that's that. Then pedantic to use ANSI. All warnings about all warnings. Yeah, so that instead of using the string locator character, that's so I think now you can see the importance of whiteboarding. If I had whiteboarded first, I wouldn't have needed to do all of this debugging here and look and see all of this research. Let's see again for more. Okay, so you can see it works the same. Let's see for an empty string. An empty string. So just let me. So now that you're alone, Velma, let me ask you what in pointers really affects you?
In pointers.
Yeah, pointers, arrays, and strings.
I had issues with using, for example, the example that you were giving, instead of using the array,
Yes, pointer
use
arithmetic.
it, yeah, pointers arithmetic.
Okay, so 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 pointer arithmetic. Okay, for that one.
Yes, and using pointers in multi-dimensional arrays.
Okay, for multi-dimensional arrays, we shall look at them later. But for pointer arithmetic, let's see. So we have online C compile. Did you check the YouTube videos given by Alex?
About pointers,
Yeah.
yes.
So I'll start by saying the thing that made C actually the improvement that C made from its predecessor was the improvement that C made from its predecessor was to
Yes.
data types, each data type a size. Okay. Now when you declare a variable, for example, in this particular case, if I declared int x, okay. Now
Yes.
at this particular point, once they compile this code, okay, the compiler will segregate a particular segment of memory to store this in X. Okay,
Yes.
up to there we are okay, right? So
Yes.
on most 64-bit machines, an int is 4 bytes. Okay, so it would
Yeah.
segregate 4 bytes, and 4 bytes is simply 32 bits. Okay,
Yeah.
so it would segregate there just 4 bytes, and just like that. Now, or just a particular segment of memory, right? Okay. So that area is segregated to store this particular integer. Okay. Now, what what the thing about pointer arithmetic to understand is that, so for example, if I say instead y and I initialize it to x, so when I initialize it like this, okay.
Yes.
So when I increment y, when I say y plus 1, okay, when I increment y or y plus 2 or y plus 3, so I don't know if I have this in my raw whiteboarding so that I can be able to draw. Okay. So the thing about it is that when you increment y, okay, so instead
Yes.
of going to the next byte, okay, it will take the
Yes.
size of that variable that it is pointing to, okay.
Yeah.
You get it? The size of that variable that is pointing to, and then skip that size, okay? When you
Yeah.
increment by 1, okay?
Yes.
So when you increment by 2, it will take 2 of those, okay?
Yeah.
Okay.
So it means, for example, if we had int x at address 400 to 403, so the next will be 404.
Yeah, simply means that. The next will be 404. It won't move. So let's try to see it practically. So if we printed address of x now, then and p, then I said, then we gave y, right? Okay, you see. Sorry, I'm having a shitty laptop. Actually, it's borrowed, but anyway, it's thank God for the laptop. But then, so what I'm saying here, okay, if I said int x, then I said it. Now that's where the pointer types come in, okay, and I gave it the
Yeah.
address, okay. So when this code runs, x will have a variable stored. Now the address where that variable will be stored, okay, the address is what y will hold. Y will hold the address of that particular variable. Up to there we are together, right?
Yeah.
Okay. Now, so we can see like this. Okay. So we say address x is then %p. Then I give y. Okay. Y
Yeah.
is a pointer, and the value of y is the address of x. Okay. Then I increment y. Let's just do +1. Y +1. Okay. You see it now. Now this one won't go. It will now move to the next. Okay. So
Yeah.
let's first run this. Okay. So you see, this is the address. Okay. It gives us
Yeah.
14. Okay. But then when I after I increment it, okay. See, see, okay, I haven't in this particular case. So you understand when I say y plus equals 1, right?
Yeah.
Yeah, okay. So when I run it, this particular, so I do this. Okay. Now you see it has incremented by 4, not 1. You see,
Yeah.
because
Yeah.
an int is 4 bytes, right? In this
Yeah.
particular place. So an int is 4 bytes. Now, if it was a double, okay, I think a double is also 4 bytes. I think so. But let's see. I'm not sure. I'm not sure the size of a double. We don't use them a lot. So I'm not sure of its size. Okay. So a double should be 8.
Yeah.
So you see in this particular case, it has moved 8 bytes, okay?
Yeah.
Okay, now I think I would have drawn it. Now when we increment by 2, it won't move. It will now, you see, so each increment will increment by the size of the data type which the pointer is pointing. Okay?
Yeah.
Each incrementing by 1. Each time you increment by 1, it increments by this. Okay? You get it now.
Yes. Yes. I get this.
Okay? So when you add, that's just what it will do. So that's what it will do now. It will segregate that number of bytes and it will now give you that.
Okay.
Okay? So that's that. Now, and you understand dereferencing.
Yes.
So now when you dereference a pointer, it gives you the value stored at that particular address, right?
Yeah.
It gives the value stored at that particular address. And then now when you have a pointer to pointer, then it becomes now. But then again, for that, I think, okay, I think, which country are you from?
Kenya.
Oh, so I'm also from Kenya. Okay.
Oh, okay.
Okay, but anyway, the point is, okay, I'll post the link to this. I'll post it on YouTube, this video, and then post it in the group, and then you can reach out so that we do the pointers tasks on Saturday. We do all of them, okay?
Yeah.
Especially for the double
Sure.
pointers and multidimensional arrays, okay?
Okay.
But
Sure.
then the thing is, to understand pointers, I think you have the video that was given by my code school. Was it my code school or string or free code camp? I don't quite remember. But then,
I'm not sure.
but
There
then,
was a video I watched. It was almost 3 hours.
that was not. I don't think that was given by Alex. I think that that one you found it by yourself.
But it was explaining so well. So,
Yes.
but the issue is I got an issue with the array. Was it multidimensional, especially the 3 dimensional?
mu-
But
Multidimensional arrays.
yeah,
Okay. Now, multidimensional arrays, they go with double pointers actually. So
yeah,
you remember I said that when you have an array, it gives you the value at that particular location, right?
yeah,
So when you have a double pointer, it's a pointer to a pointer, right? A pointer that holds the address of another pointer, right?
yeah.
So in this particular case, it would go to that point. So in this particular case, it would go to that pointer. So the multidimensional array, it will reference it twice. Okay, it will go to
Yeah.
that pointer, and that pointer will be holding another pointer. Then the multidimensional array will then go to that now other pointer and get its value. Okay, and like that. Okay, it moves on like that. Okay,
Yeah.
okay. But just for your sake, let me try to implement a simple puts function. Would that be okay, or you're tired?
Okay. Just one example, and then probably we can meet on Saturday. You said on Saturday.
Yeah, yeah, Saturday. Okay, I'm still
I,
on recursion task.
you are going to hold a class.
No, why would I? This is just to ensure you. Without pointers, there's very little you can do in C without pointers.
Yeah.
Okay, you'll soon see it when we. Have you read on Malloc?
Yes. A little bit of it. Malloc, Carlock, and the free. I read a little bit of it, but then I was like, I'm not going to get these concepts before I get how pointers works in the array. So
Yeah, so that's that. So it's very crucial that you understand pointers. For you to understand malloc for function pointers, there is very little you can do in C because pointers are genius because what they do is that they how do I say this? How do I say this?
I was there that time. I was reading about pointers. I was like, there was a time. If you want to access values or anything inside the memory,
Yes.
there is a need for you to know how to use pointers because most of the time to access the values stored inside the memory, you'll need to know how to use pointers,
Yeah, that is true.
especially if they are saved inside the dynamic memory. So, but
No, the thing is, pointers, instead of creating a new variable that copies the old variable, simply the thing is that is pointers. What the pointers do is that they simply now, how do I say this? They simply give you access to the value stored at that particular address, which saves a lot of memory. Okay, so STR Kenya. here. This is mine. Oh, so puts, the puts we use actually. I think we'll come back to puts in printf as prints lento. Yeah. We'll come back to puts in printf, but puts actually returns the number of characters that it prints out. But why do I keep forgetting? Something's wrong with me today. Set but not used str undeclared. Ah, that's okay. Okay. So puts pointers. Now, in this particular case, I used, instead of dereferencing it using the dereference, the star, I'm simply dereferencing it using arrays. You see it, right? Velma. Velma. Okay. So I'm simply dereferencing it using arrays and incrementing it and getting the length. Simple. That's just all I'm doing. So it's simply, I do that. I get error out.
Are you there?
Yeah, I'm there. I'm still there. So here I'm counting. So prints a new line at the end, right? I knew this would come through. So it's okay. That's that. Now, what I'm simply doing here, okay, in this particular case, is that I simply come here and I take here. I mean, I'm dereferencing it using arrays. I mean, I find arrays easier to dereference with because for pointers you'll have to use multi-dimensional array. You'll have to use double pointers. You'll find yourself making 3 stars in the beginning just to dereference one pointer and get the value of that pointer. But with arrays are more intuitive. And then I think this code is self-explanatory, right? Velma.
Yes, sorry, I had an issue with my network.
Okay, fine. But then I think the puts function that I've written is actually it's a modified version of the puts that you are given. And that it simply comes and it simply, what does it do? Yeah, just like that. It simply gets the iterator here, and then it checks if the value at that particular address, the pointer from the string there, if it's equal to null. If it's not equal to null, then it goes ahead with the loop. When it gets to null, it stops and then it prints a new line. You know, the put prints a new line. And this len plus plus that I've added here, it simply counts the character being output by the new line. Okay. Okay. So that's just that. And now with pointer arithmetic, I mean, so instead of the thing I like about arrays more is that instead of using pointer arithmetic to get the value of a particular address and then putting the brackets and dereferencing it, when you use arrays with pointers, you simply get that value by giving the value of that address instead of adding and doing all that.
Yeah.
Okay. So so I think this is just this. So did you, which task are you on right now?
Right now we are in the recursion.
No, I'm asking which one. And you said you didn't do all the pointers.
Yeah, the last task I did on pointers was the accept.
the string span,
Yeah.
the one that I've just done,
Yeah.
and the string character, the
And
STRCHR.
yeah, I still have some issues with those functions. I want to work on that,
Okay. Maybe.
on understanding how those functions work.
Okay. Okay, that's actually the tricky part, understanding how the functions work, because the man pages are not very clear,
Yeah.
as you can see. And then I did all of them. I think if I'll just get back to, let's do our recursion tasks, and then
Mhm.
tomorrow I'll see why we'll see where we are going. Okay.
Okay.
Fine. Thank you for coming.
Okay. Thank you.
Thank you. See you later.
Okay. Bye.
Bye.